400 billion stars in our galaxy, at least 100 billion rocky planets sitting in the habitable zone. The universe has had 13.8 billion years to work with, and in 65 years of searching with our most powerful instruments, scanning millions of stars, processing 12 billion signals, we've found absolutely nothing. Not one message. Not one artifact. Not one hint that anyone else is out there. And by the end of this story, you'll understand why every new discovery, every planet, every drop of water we find actually makes the silence more terrifying. Because the answer to this question might determine whether humanity survives. Summer 1950. Los Alamos, New Mexico. 4 nuclear physicists walk to lunch. Enrico Fermi, Edward Teller, Herbert York, Emil Konopinski. They'd been joking about a New Yorker cartoon, aliens being blamed for missing trash cans in New York City, flying saucers, interstellar travel. Standard lunch banter for men who'd helped build the atomic bomb. Then Fermi went quiet. His colleagues knew what that meant. They called him the Pope, because in physics his pronouncements were infallible. When Fermi stopped talking, he was calculating. And then, mid-conversation, he looked up and asked, "Where is everybody?" Edward Teller remembered. The result of his question was general laughter, because everybody at the table seemed to understand at once that he was talking about extraterrestrial life. But the laughter faded, because Fermi wasn't joking. Herbert York recalled that Fermi followed up with rapid calculations. The probability of Earth like planets, the probability of life, the probability of intelligence, and he concluded that we should have been visited long ago. Many times over. The math said yes, the sky said no. And that contradiction between the overwhelming probability of alien life and the total absence of evidence would become one of the most haunting unsolved problems in all of science. But here's the part that makes it personal. Because Fermi wasn't just calculating the odds of alien civilizations, he was accidentally calculating the odds of our own survival. 11 years later, November 1961, Greenbank, West Virginia, astronomer Frank Drake gathered the first scientific meeting ever held on extraterrestrial intelligence. To structure the conversation, he wrote an equation on the chalkboard. N equals R star times FP times NE times FL times FP times L, 7 factors. Star formation rate, fraction of stars with planets, number of habitable worlds, fraction where life evolves, fraction that develop intelligence, fraction that build detectable technology, and the average lifespan of such civilizations. Drake's original estimate? Somewhere between 1,000 and 100 million civilizations. In our galaxy alone, the room included Carl Sagan, 27 years old, already brilliant, and Melvin Calvin, who received a phone call during the meeting telling him he'd just won the Nobel Prize in Chemistry. The first scientific meeting about alien life literally had a Nobel announcement interrupt it. Now, here's what's changed since 1961. We used to guess about planets. Now we know. NASA's Kepler mission proved that virtually every star has them. As of 2026, we've confirmed 6,147 exoplanets. At least 1 in 4 sun-like stars hosts a rocky world in the habitable zone. The numbers got better. The silence got worse. If you're watching this and wondering why that's terrifying, subscribe, because the next part is the one that keeps physicists awake at night. In 1996, economist Robin Hanson asked a question that turned the paradox into an existential threat. If the ingredients for life are everywhere, and they are, then why is the universe empty? Something must be stopping civilizations from reaching the stars. Some barrier, some wall. He called it the Great Filter. Think of the journey from dead matter to a galaxy-spanning civilization as a staircase. Somewhere on that staircase, there's a step that's nearly impossible to pass. A filter that kills almost everything that reaches it. The question is, where is it? If the filter is behind us, maybe the origin of life was astronomically unlikely, a 1 in a trillion accident. Then we're the lucky ones. We already passed the hard part. The universe is silent because life almost never gets started. But if the filter is ahead of us, then every civilization that reaches our level eventually destroys itself. Nuclear war, runaway AI, climate collapse, engineered pandemics. The filter isn't rare biology. It's inevitable self-destruction. And here's the twist that makes this genuinely unsettling. Every time we discover that life's building blocks are common, that amino acids form in space, that water exists on moons, that habitable planets are everywhere, we're pushing the filter forward. Closer to us, closer to our future. Good news in astronomy is bad news for the Fermi Paradox. Hansen wrote, "Humanity seems to have a bright future. But the fact that space near us seems dead now tells us that any given piece of dead matter faces an astronomically low chance of begetting such a future." There's another answer, and it's worse. In 2008, Chinese science fiction author Liu Cixin wrote a novel called The Dark Forest. In it, the universe isn't empty. It's full of civilizations, but they're all hiding. The analogy, imagine a dark forest at night. Every civilization is a hunter, armed, silent, listening. Any creature that makes a sound, any civilization that broadcasts its location, invites destruction by someone more advanced. The safest strategy? Stay quiet, stay dark, and if you detect someone else, eliminate them before they eliminate you. It's fiction. But it changed the real scientific conversation. Because we haven't just been listening, we've been shouting. The Arecibo message, Voyager's golden record, our television signals leaking into space for decades. If the dark forest hypothesis is correct, we've been lighting a bonfire in a forest full of hunters, and we can't take it back. We haven't stopped looking. In 1977, Ohio State's Big Ear telescope picked up a signal from the direction of Sagittarius. Powerful. Narrowband. Exactly what an alien transmission should look like. Astronomer Jerry Emon, a volunteer, not even paid for the work, circled the reading and wrote "wow" in the margin. The signal lasted 72 seconds. It was never detected again. Nearly 50 years later, it remains unexplained. SETI at home ran for 21 years. 12 billion candidate signals processed by millions of volunteers worldwide. They narrowed it to 100 final candidates. China's FAST telescope, the largest radio dish on Earth, is following up on everyone. All are expected to be terrestrial interference. The VLA Sky Survey scanned 950,000 positions across the sky. 0 artificial transmissions. But then, 2024, the James Webb Space Telescope detected something on a planet called K218b, 124 light-years away. Dimethyl sulfide on Earth. That molecule is produced exclusively by living organisms, marine phytoplankton. The concentrations were thousands of times stronger than on Earth. Lead researcher Niku Madhusudan said, "A Hycean world with an ocean that is teeming with life is the scenario that best fits the data we have. It's at 3 sigma significance, not confirmed yet, but it's the strongest hint of life beyond Earth we've ever found. And if it's real, the Great Filter just moved forward. Maybe they're watching us like a nature reserve. The zoo hypothesis? Observing but never interfering. A cosmic prime directive. Maybe they're hibernating." In 2017, philosopher Anders Sandberg proposed the aestivation hypothesis. Advanced civilizations might be waiting for the universe to cool down. Due to thermodynamic principles, stored energy becomes 30 orders of magnitude more efficient in a colder universe. They're not dead. They're sleeping, waiting for cosmic winter. Or maybe, and this is the answer that's both the simplest and the most profound, we're early. The universe is only 13.8 billion years old. The conditions for rocky habitable planets may have only become common 4 or 5 billion years ago. We might be among the first wave of technological civilizations in the cosmos. The silence isn't a warning. It's an empty room waiting for the first voice. Here's what stays with me. Fermi asked his question over lunch, a casual moment between bites of food. He died 4 years later at 53, never knowing he'd created one of science's deepest puzzles. We've spent 76 years listening, 76 years of silence, and somehow the silence itself has become the most important data point in all of astronomy. Because the answer, whichever one it turns out to be, changes everything. If we're alone, this is the only place in the universe where anyone is asking questions. If we're not alone but nobody survives long enough to reach the stars, then the next century is the most dangerous in human history. Either way, the silence is trying to tell us something. We just haven't learned to read it yet. Remember Fermi's lunch? 4 physicists, a cartoon about aliens, and a question that silenced the table. 76 years later, we have 6,000 planets, a possible biosignature, and the same 5 words. Where is everybody? The universe doesn't answer. It just keeps expanding, and the silence keeps getting louder. Speaking of questions that change everything, there's one hiding in your blood right now. In 2025, a team built a test that can detect 50 types of cancer from a single blood draw. Before you feel a single symptom, the science behind it started with a widower who lost his wife to a cancer caught too late. And what he built might save more lives than any drug in history. Title suggestions. 5 options. 1. The Fermi Paradox. Why 400 billion stars produce 0 signals. 2. 76 years of silence. The Fermi Paradox explained. 3. Where is everybody? The most terrifying question in science. 4. 12 billion signals searched. 0 aliens found. Here's why. 5. The universe should be full of life. It's empty. Fermi Paradox